Long before the first B-21 Raider ever took to the sky, the most important decision had already been made. Not about stealth, not about speed, not about weapons, about something far less visible. Because by then, the Pentagon had already spent decades learning one expensive lesson. Building a revolutionary aircraft was never the hardest part. Building the program was every delay, every cost overrun, every changing requirement, every lesson learned the hard way, forced the Pentagon to rethink how America's next bomber would be built. When work quietly began on the B-21 Raider, the goal wasn't simply to replace the B-2 Spirit. The goal was far more ambitious, to prove that America could still build one of the world's most advanced military aircraft, without repeating the mistakes that had haunted some of its biggest defense programs. The question was no longer, can America build another stealth bomber? History had already answered that. The real question was, after decades of success and decades of costly lessons, had the Pentagon finally learned how to build one differently? The answer began years before the first piece of metal was ever cut. The B-21 Raider wasn't born because America wanted a newer bomber. It was born because time was running out. For decades, the United States relied on 3 aircraft to carry out its longest-range strike missions: the B-52 Stratofortress, the B-1 Lancer, and the B-2 Spirit. On paper, that sounded like a powerful force. In reality, each bomber had a different problem. The B-52 could carry enormous payloads, but it was designed during the Cold War. The B-1 could fly faster, but years of heavy use had taken their toll, and the B-2, the world's first operational stealth bomber, was one of the most advanced aircraft ever built. But only 21 were ever produced. Today, even fewer remain in service. Losing even one would be a serious blow. For years, the Air Force faced a difficult question. How do you replace an aircraft that was never built in large numbers without repeating the mistakes of the past? Because replacing the B-2 was never as simple as building another bomber. The next aircraft had to survive a very different world. Long-range missiles, advanced radar networks, integrated air defenses, and potential conflicts stretching across the vast distances of the Pacific. The challenge wasn't simply building something better, it was building something that could remain relevant for decades. And that challenge forced the Pentagon to rethink almost everything. Because before engineers could design the aircraft, they first had to decide how they were going to build it. Before the Air Force approved a single blueprint, before the first piece of metal was cut, something unusual happened. The Pentagon looked backwards, not forwards, because the B-21 wasn't the first ambitious military aircraft America had tried to build. Far from it. For decades, the United States had pushed the limits of military aviation. Some programs became legendary, others became cautionary tales. Each one left behind lessons, written in years of delays, billions of dollars, and engineering compromises. The biggest lesson wasn't about stealth, or engines, or even software. It was about complexity. Every new requirement seemed reasonable on its own. A more powerful radar, better communications, longer range, lower maintenance, greater survivability. Each improvement promised a better aircraft. But together, they created something far more difficult, a program that became larger, slower, and far more expensive than anyone expected. By the early 2010s, the Pentagon had reached a difficult conclusion. The problem wasn't America's engineers. The problem was how military programs were being built. That realization changed the conversation. The question was no longer, how do we build a better bomber? It became, how do we build a better procurement program? That meant changing decisions years before production began. Fewer changing requirements, more realistic schedules, greater use of digital engineering, and a design philosophy built around future upgrades instead of constant redesigns. It sounded simple. In reality, it required changing decades of procurement culture, and the first test of that new philosophy would happen long before the aircraft ever reached a runway. It would happen inside a computer. Before the first sheet of metal was cut, the B-21 already existed, not inside a hangar, not on a runway, inside a computer. Every panel, every structural beam, every cable, every hydraulic line, even parts that mechanics might never see, had already been assembled, tested, taken apart, and rebuilt, without anyone touching a real aircraft. It sounds almost impossible. Build an airplane without building an airplane? But that's exactly what the Pentagon wanted, because by then, they had learned another expensive lesson. Finding a problem after production begins is one of the fastest ways to turn millions of dollars into billions. Imagine constructing a skyscraper, only to discover halfway through that the elevators don't fit inside the building. You can fix it, but every change means tearing something else apart. Aircraft programs work the same way. A single design change can affect thousands of parts, delay production, force new testing, rewrite software, and push costs even higher. The Pentagon wanted to catch those problems before the first machine inside the factory ever switched on, so engineers created what is known as a digital twin, a complete virtual version of the aircraft, not simply a 3D model, but a living engineering system, one that allowed teams to test, modify, and improve the bomber long before the real aircraft existed. It wasn't perfect. No digital model ever is, but it allowed engineers to solve problems, when solving them was still relatively inexpensive. Instead of discovering mistakes, after hundreds of people were already building the aircraft, it was one of the biggest changes ever made to an American military aircraft program. But building the airplane twice solved only one problem. The next challenge was making sure it wouldn't become obsolete before it even entered service. Imagine buying the most advanced smartphone in the world, then discovering 5 years later that it can no longer run the newest software. The hardware still works, but the technology around it has already moved on. Military aircraft face the same problem, except they aren't replaced every few years. Some remain in service for 40 or even 50 years. That creates a challenge most people never think about. How do you build an aircraft today that can still fight wars decades from now? The answer isn't predicting the future. Nobody can do that. The answer is designing an aircraft that expects to change. Previous generations of military aircraft often relied on tightly connected systems. Replace one computer, and suddenly another system no longer works. Upgrade a sensor, and months of software testing begin all over again. Small improvements could quickly become major engineering projects. The Pentagon wanted something different, a bomber that could evolve without constantly starting over. Engineers call this open architecture. Think of it like building a house. If every wall supports the roof, changing one room means rebuilding the entire structure. But if the walls are designed to be moved, the house can change without bringing everything down. The B-21 follows the same philosophy. Its software, mission systems, sensors, communications, and future technologies were designed to be upgraded without redesigning the entire aircraft. That may not sound as exciting as stealth or hypersonic weapons, but over the lifetime of a bomber, it could become one of the most important decisions ever made, because the most dangerous enemy of any military aircraft isn't always another aircraft. Sometimes, it's time, and while engineers were trying to solve that problem, another challenge was waiting, one that couldn't be solved. Inside a factory, it would be decided thousands of miles away, across the Pacific Ocean. Long before the first B-21 Raider rolled out of its hangar, the aircraft already had an enemy, not a fighter jet, not another bomber, an entire defense network, because modern wars are no longer fought against a single radar or a single missile battery. They're fought against systems designed to work together. Imagine trying to sneak through a city where every security camera, every police officer, every traffic camera, and every emergency dispatcher shares information instantly. Avoiding one camera doesn't matter. The next one already knows where to look. That's how modern air defense works. Ground-based radars, airborne early warning aircraft, long-range missile batteries, electronic warfare units, military satellites. Each one sees only part of the battlefield. Together, they create a single picture. Military planners call it an integrated air defense system. For decades, bombers relied on speed, altitude, or electronic jamming. The B-21 was built around a different idea. If the network never finds you, it can never coordinate against you. That sounds simple. It isn't. Stealth isn't invisibility. It simply reduces the chances of being detected. Every radar that fails to see you, every sensor that loses your position, every second you remain hidden, increases the chances of completing the mission. Because in modern warfare, finding the target is often more important than destroying it. And that's exactly why the B-21 wasn't designed to fight yesterday's wars. It was designed for wars that haven't happened yet. But building an aircraft for the future creates another problem. How do you know whether you've actually succeeded before that future ever arrives? The B-21 Raider hasn't fought a war. It hasn't faced enemy fighters. It hasn't flown through the world's most advanced air defense network. And because of that, no one can honestly say how it will perform in combat. That answer still belongs to the future. But one thing is already different. The B-21 wasn't built the same way as many of the programs that came before it. Its requirements remained more disciplined. Its design relied heavily on digital engineering. Its systems were built with future upgrades in mind, and throughout its development, the Pentagon repeatedly emphasized affordability, manufacturing, and long-term sustainability. Those may not sound like revolutionary ideas, but in defense procurement, they can determine whether a program succeeds or spends decades chasing problems that could have been avoided. That doesn't mean the B-21 is guaranteed to succeed. Military history is filled with programs that looked promising, until reality tested them. Budgets change, threats evolve, technology moves faster than expected, and every new generation of weapons introduces challenges that nobody predicted. The real test of the B-21 won't happen during its rollout, or during official ceremonies. It will happen years from now when the aircraft begins operating, in a world that is still changing. Only then will we know whether the Pentagon truly learned from the lessons of the past. Because the B-21 isn't simply another stealth bomber. It's a different way of thinking about military procurement, a belief that building smarter can be just as important as building stronger. If that belief proves correct, the B-21 may influence every major American military program that follows. If it doesn't, the search for a better way to build the future will begin all over again, and that's what makes the B-21 Raider more than just another aircraft. It may become the program that determines how the next generation of American military technology is built. Sometimes, the most important weapon isn't the aircraft itself, it's the lesson it leaves behind.